In 9.5, we will be discussing hyperbolas. For those of you who have been following along the last few lessons, you should find it as no surprise that first we're going to talk about how to graph hyperbolas. Then we're going to learn how to write the equation for a hyperbola given particular information. Then we're going to find, the new one for today is asymptotes. Hyperbolas have asymptotes. So finding the equation for asymptotes, it's not particularly challenging, but I wanted to take an extra second to talk about it just in case it comes up. So first, we're going to graph a hyperbola. The standard form for a hyperbola is as follows. It's either one of these or the other, depending on which way the parabola opens. So you'll have the x squared and the y squared again. These are a lot like ellipses. The biggest difference here is their subtraction when they're on the same side, whereas with the ellipses, we had x squared over a plus y squared over b equals 1. That was for ellipse. So instead of having addition, we're going to have subtraction. Other than that, the equation looks very similar. A and b will not be the same. If a and b, well, I guess for a hyperbola, a and b can be the same. For an ellipse, if a and b were the same, we called it a circle and multiplied it to the other side. The other difference for hyperbolas is that it does not matter whether a or b is bigger. The orientation of the hyperbola is not determined by the bigger of a or b, like they were for ellipses. The orientation of a hyperbola is determined by which one is positive and which one is negative. Now, as a gets bigger, that's going to stretch the hyperbola, but a hyperbola will either open to the right and left or up and down based on the sign of the variables, not on the size of their a and b. Let's get right in with an example. I will start with one. I will put it in standard form. X squared over 16 minus y squared over 25 equals 1. Nice, simple squares there. That's x squared over 4 squared and y squared over 5 squared. So right away we have the information we need. Now you can think of hyperbolas in a lot of ways as the opposite of an ellipse. Or if you like, an ellipse that exploded, which you'll see what I mean by that when I'm actually drawing it. So the beginning of what we do for the hyperbola is going to be a lot like for the ellipse. We're going to look underneath the x, that's 4 squared. And that means we're going to move 4 to the right and 4 to the left. But those are, I guess, if those are on the one that's positive, those are actually the vertices of our hyperbola. But we're nowhere near being ready to draw the hyperbola. We need to look underneath the y, 5. We'll go up 5. Oh, I don't think I left enough room. Down 5. I should have gone by 2s. I'll make it work. But when you draw these, it doesn't, if this were an ellipse, if these were both positive, the ellipse would belong inside and we could draw our ellipse now. For a hyperbola, these actually mark off a box. Now the box is not technically part of the hyperbola, so when I draw the box, I'm going to use a dotted line. And really, drawing the box is optional, but if you're getting it all stuck, the box will really help you. It helps to define the shape of the hyperbola when we get there. So each one of these then, the plus and minuses that we just did, mark an edge of the box. And the box has 4 corners. In order to draw the hyperbola, you need the asymptotes. And it turns out each asymptote will go through along a diagonal of this box. So one asymptote goes this way, and the other asymptote is going to go this way. So you draw the box, and then you put the asymptotes diagonally through the corners. And this gives you the structure you need to draw your parabola. Now, whichever one is positive, in this case the x is positive, so that's the direction we're going to go for our vertex right here at 4, 0. It's the vertex, or one of the vertices. There's one on either side. And then we're going to come right from our vertex to our asymptote. And it just does this. When we saw hyperbolas back in chapter 8, the asymptotes were perpendicular. And so the shape may look a little different to you, but as long as you come from the vertex through the asymptote, you'll be fine. And as I've seen on graphs before, based on the way my wrist moves, I'm going to have an easier time drawing this one if I turn my paper upside down, because that's just the way my wrist naturally wants to bend. And if I try to do it from the other side, I can do it. It never looks quite as nice. So there is a sketch of this hyperbola. It has vertices at 4, 0 and negative 4, 0. The asymptotes, if you're just graphing, you can draw them and not worry too much about the equation. But I am going to take a minute here and explain about the equation. Today, all of our vertices are going to have all of our hyperbolas are going to have their center at 0, 0. So the equation for any line is just going to be y equals mx plus 0, because they're all got a y-intercept at 0. So all I need to do is figure out the slope, and it turns out the slope is up 5 and over 4 for this one. So this asymptote is y equals 4/5 x. And then this one, it's got the same slope but negative, down 5. Oh, I wrote that upside down. It was up 5 and over 4. And this one is down 5 and over 4, so negative 5/4 x. And that's my two asymptotes. As far as finding the focus, in case you wanted to graph it, or later we're going to need to know where the focus is. With the hyperbola, because of the negative sign, way back when we did ellipses and we had to find the focus, we learned that the focal length squared was always the difference between the squares of a and b. That's for an ellipse. It's old information. For a hyperbola, the focal length is the sum of the a and b, the squares of a and b. So the focal length is the square of the focal length is the sum of the squares of a and b. Instead of subtracting, you're going to add a and b together. Now, that one of the things that means is that the focal length is going to be longer than the vertex, which shouldn't really surprise you, because the way this graph curves, you should expect the focus to be on the interior of the curve. And this is one of the things I mean by it's kind of like an ellipse that bursts. If you think about an ellipse, and the ellipse gets bigger and bigger, and it pops to the other side. And so it's actually moving away from the center instead of toward the center. So it's like kind of like it exploded. At least that's what I think. So the focus is going to be out here somewhere. To figure out how far, I'm going to say that c squared equals 4 squared plus 5 squared, which is 16 and 25, which makes 41. Unfortunately, that makes c the square root of 41, somewhere between 6 and 7. So this is 4, 5, 6. It's really very close to halfway, I think. Wait, 4, 5, 6. Sorry. Here. 4, 5, 6. Somewhere between 6 and 7. Because 6 squared would be 36. 7 squared is 49. We're somewhere in between. Square root of 41, 0. And 4, 5, 6 and a half. Negative square root of 41, 0. Finding it exactly, not important. But I guess some of you might prefer that. So square root of 41, 6.4. And there's my foci. This will also be useful, c squared equals a squared plus b squared, when we come back and try to write the equations. If what you know is where the focus is, and then in order to find a or b, you may need to use this equation. Let me graph another one. I'll graph one that is vertically oriented. All right. Let's do... Am I going to be able to fit it there? Not necessarily, so I'll switch sides. All right. Y squared over 39 minus x squared over 25 equals 1. In this case, the x squared has a very nice square underneath it. That's 5 squared. But square root of 39, that's problematic. So square root of 39 is more than 6, less than 7. It's less than 6.4. Square root of 41 is 6.4. All right, so let me leave more room than I did last time. All right, the underneath the x is 5 squared. So 1, 2, 3, 4, 5 to the right, 2, 3, 4, 5 to the left. This one needs to be more than 6. 6.2 or 6.3. I'll get that exactly for you. Square root of 39, or more exactly anyway. More precise. 6.24. So 6 1/4. 1, 2, 3, 4, 5, 6 1/4. About where I drew it. So the 4 corners are going to be here, and here, here, and here. So those are the 4 corners of my box. You are welcome to draw the dotted lines. Like I said, they're technically optional. I'm going to not draw them this time. That's a little high. Draw my diagonal asymptotes. There's one up there. Now you can draw this all the way through like I did last time. Although the part that really needs to concern you is out on the end, because that's where the graph is going to approach it. So if you don't want to have so much going on your paper, you can do it like this. Now the vertices are going to be here, 0 square root of 39, and 0 negative square root of 39. And then this one's going to go from the vertex to the asymptote. Because the y is positive, the parts of the hyperbola are going to be above and below rather than left and right. And there's this one. It's also pretty wide. I should make sure I draw one that's skinny. Sometimes they're pretty skinny. Okay, so that's graphing a hyperbola. For the first example of part number 2, writing the equation, I'll make one that's super skinny. So let's do another horizontal one, but make it super skinny. So we're going to imagine then hyperbola. Draw a box. Oh, I should have done that dotted. Life goes on. So we're going to imagine this hyperbola, which you'll note is much skinnier than the ones we've seen before. Now in this case, we know A and B. We know that A is 3, because that's how far left and right we go to get to our vertex. We know that B is 1, because that's how far up and down we go to get to the edge of our box. It is possible you could have been given the vertex and also the equation for the line, y equals 1/3 x, the asymptote there. In which case, because you know A is 3, B is the 1. And then you'll be able to find A and B that way. The equation for this then is just, we have to figure out which way the hyperbola is actually pointing, which is left and right. So the x squared is one that's positive. And that's how I know A is 3 as opposed to B being 3. So underneath that I put 3 squared, which is 9. And underneath the y squared, 1 squared is 1. There is the standard form equation for this particular hyperbola. So most of the time, at least in your book, the way this is going to work out, rather than giving you a picture showing you what A and B are, they're going to ask you to write the equation given the focus, one of the foci or both foci and the vertices. So let's assume that we have foci at -6, 0, and 6, 0, and vertices at -2, 0, and 2, 0. Your vertices and your foci for the hyperbola should always be on the same axis. So in this case, the fact that they're in the x direction is significant. You can sketch a picture of this if that will help you. Although I know just from the fact that these are the vertices that A is going to be how far away the vertices are from the origin. Which means A is 2 in this case. And since the foci are 6 away from the origin, C is going to be 6. C squared equals A squared plus B squared. So 36 has to equal 4 plus B squared, which makes B squared 32, which isn't going to work out nicely, although we can simplify it because the square root of 32, I have no reason to simplify it. B squared is what I need. That'd be 4 square roots of 2, but it doesn't really matter because all I needed was B squared. A squared is 4, B squared is 32, and A squared is, the A goes in the x direction, so the x is going to be the one that's positive. X squared over 4 minus y squared over B squared is 32 is 1. All right. I already talked a bit about writing the equation for the asymptotes. The only thing you have to worry about is which one is the rise and which one is the run. So your book lists them as two separate equations, and I think mostly just expects you to memorize that this one is y equals b over a, and this one is y equals a over b. But it's just rise over run. So if you can draw the box, you can count the slope. 5/4 for this one. This one was square root of 39 over 5, which is very annoying, but doable. All right. Guess that's all 3 things I was supposed to teach you. Write the equation, graph the function. Yeah, we're good. Good luck.